Okay, so moving on to the next learning target, we're going to start talking about what happens when we have something with an exponent raised to another exponent. It's kind of like exponent inception, okay? And the biggest part of this learning target, and I've put it right here, is that parentheses really matter. More than any other thing we've done, parentheses are extremely important in this learning target. So when I'm telling you guys to use parentheses, it can't be the kind of thing, where, oh, she said to use it, but I can do it without. I can't very often do it without parentheses, okay? They're extremely helpful, and we've got to practice using them. And in this example, notice how all of these say, like, 2x to the fourth, 2x to the fourth, and this is a little bit different, but it's all generally 2x to the fourth. The only difference between all four of these problems is where the parentheses are, okay? Like, in this one, they're around 2x. In this one, they're around 2x cubed. In this one, the 2's on the outside and the x cube's on the inside. And in this one, I don't have any. All of these have very different outcomes, okay? So let's take a look at how parentheses can affect the problem. All right, so the first one, 2x to the fourth, okay? If we have 2x to the fourth, we can't simplify this any further, right? The 2 is not attached to the 4. This is saying 2 times x to the fourth. You're not taking 2 to the fourth power, so it just stays the same, 2x to the fourth. There's no change here, okay? Now the next problem is a lot different even though it looks similar, okay? This is now saying the 2x to the fourth power, which is something that looks like this. I have 2x times 2x times 2x times 2x. You're saying that you're going to multiply 2x 4 times, okay? Because that 4, the 4 applies to the entire term 2x, which is very different than 2x to the fourth, okay? So when we have this situation, now that the power is gone, now I treat this the same as last learning target. I put all my 1's up here, and then I add them all together. So x times x times x times x gives me x to the fourth, because 1 plus 1 plus 1 plus 1 is 4. Okay, I like to cross things off once I'm done. What is 2 times 2? Well, that's 4. Done. What's 4 times 2? 8. 8 times 2 is 16. So parentheses 2x to the fourth simplifies to 16x to the fourth. So we have a different solution than the first problem. This next problem now has an additional exponent put into it. So I'm not saying 2x to the fourth now, I'm saying 2x to the third to the fourth. It's an exponent raised to another exponent. We treat it the same way we treated the last problem, where we're really saying 2x to the third times 2x to the third times 2x to the third times 2x to the third. So when I've got my numbers here, 2 times 2 times 2 times 2, that's the same as before, right? That's still 16. So that's the easy part. Now we have to handle the x to the third times x to the third times x to the third times x to the third. Well, last learning target we learned that all we have to do is add these up. 3 plus 3 is 6. Then 6 plus 3 is 9. 9 plus 3 is 12. So we're going to have 16x to the 12th, okay? And then the last problem is very similar to the green problem, except now I only have parentheses around the x to the third. So what this is saying is it's saying, hey, look, we've got this 2 here, but we're not going to do anything with it. We're not raising it to the fourth power. It's just kind of hanging out. So I'm going to put the 2 here, and that's all I'm going to do with the 2. Because the 2 is not in the parentheses. Really critical difference here. The x to the third, on the other hand, that's what's being raised to the fourth power. So now I'm going to have x to the third times x to the third times x to the third times x to the third. Okay? So the 2 just comes down. We're not multiplying it by anything. And then we have 4 3's, which gives me 12. So I want to be really clear here about how parentheses are important and they affect how we do the math, okay? Now, there's a shortcut for dealing with this kind of problem where you've got an exponent to an exponent. And we're going to explore that in the next 3 problems and try and figure out what that pattern might be so that I don't have to write these out every time. That takes a really long time. There has to be an easier way. Just like in the last learning target, there was an easier way. So I've got 3 example problems to see if we can find a pattern. Okay, so in the first example, it says 3n to the 4th raised to the 3rd power. So basically I'm saying that I've got 3n to the 4th 3 times. So I'm going to have 3n to the 4th times 3n to the 4th times 3n to the 4th times 3n to the 4th. Okay? Well, now we do what we did in the last learning target. Now, I like to use my calculator for things like this. I don't like doing math in my head, and 3 times 3 times 3 times 3 is something I want to be careful about. So in my calculator, I'm just going to put 3 times 3 times 3 and then times 3. Okay, and I'm going to get 81. So all of those 3's become 81, and then I like to cross the 3's off. Okay. So now I've got 4, 4, 4, and 4. If I add that up, that's going to give me 16. So my simplification of this is 16. So when we simplify these expressions, we tend to want one coefficient, so one number in front, and then we want only one exponent to each base. I don't want 2 exponents in my simplification. I just want 1 exponent. So see how in this problem I had a 4 and a 3 as exponents? I want to get rid of that second exponent and make it into 1 exponent. Okay? So if you take a look, oh gosh, guys, I made a mistake. This should only be 3 of them. I made them 4. Ha 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 ha. Okay, well that changes this. I'm not gonna edit. I'm not gonna go back. I'm gonna, encourage that you guys be okay with your mistakes. So this actually is 27. 3 times 3 is 9, 9 times 3 is 27, and then I've got n to the 12th. All right, cool. So I fixed that mistake. All right, my bad, guys. Okay, the next one. Remember, we're looking for a pattern for how we go from this problem to this answer. What is the pattern? Is there some mathematical pattern you're seeing? Let's try the next one. This is saying 2v squared all raised to the 4th power. So I have 2v squared times 2v squared times 2v squared times 2v squared. I'm going to do the numbers first. 2 times 2 is 4. There we go, 4. 4 times 2 is 8. 8 times 2 is 16. Okay, now add up all the 2's. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. So I have v to the 8th power. Okay, and this last one, be very careful. Negatives are terrible, but we've got to learn how to deal with them. Okay, this is saying negative x squared to the 5th power. So it's negative x squared times negative x squared times negative x squared times negative x squared times negative x squared. Okay, now the tricky part here is dealing with all these negatives, okay? Now, the way I like to think about it is that rule of 2 negatives make a positive. And since these are all 1s, I can basically say, okay, these 2 negatives make a positive, these 2 negatives make a positive, and I'm just left with 1 negative at the end. That's one trick I have for dealing with negative and positive numbers. So that means that I'm going to have a negative 1 as my coefficient. Now you can leave the 1 invisible. I'm going to leave it out so you can kind of get the idea. And now we just add the exponents together. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. 8 plus 2 is 10. So I get negative 1x to the 10th as my answer. And again, you can write it as negative x to the 10th. That is also an acceptable choice. So what's the pattern that we're seeing here? And if you don't see it right away, I'm going to kind of hint to you. The question I'm going to ask you guys is, what do you see between the 4 and the 3 that could possibly get you 12? What do you see between the 2 and the 8 and the 4 that could get you the 8? And what do you see between the 5 and the 2 to get you the 10? If you're thinking multiplication, you are absolutely correct. You multiply the exponents when you have the double exponents. When you're raising an exponent to an exponent, you multiply them. Okay? So raising a power to a power, I spelled power wrong, let me make that an O, you multiply the exponents. Now this is different than the last learning target where we added the exponents. So you have to keep track in your mind of what you're doing. Are you multiplying the two terms together and then you add the exponents? Or are you having exponent inception and raising it at power to a power and multiplying them? Okay, now the tricky part here is, well, and I'm going to try and explain this the best way I can. How do we go from, and let me erase these numbers here, because the coefficients honestly are the hardest part. It's not the exponents, it's the coefficients. So how do I go from 3 and the 3 to get 27? How'd I go from 2 and the 4 to get 16? And how'd I go from this negative invisible 1 to the 5? Well, the coefficients, you have to raise that number to that power. So one way I like to write this is I like to put a little 1 here and then make a little arrow like I'm distributing. Okay, and that tells me I'm multiplying. So 3 times 1 is 3, so I get 3 to the 3rd power. 3 times 4 is 12, so I get n to the 12th power, and then I can just put this in my calculator to get 27 n to the 12th. So I'm going to be showing you this trick all the way through the learning target, but I kind of want to point out that the coefficients also have a pattern. It's just you have to be really careful with your notation. Okay, so like we did last time, we're going to add this to our laws. Okay, so this is the second law that we're learning, and it's called the power rule. So the formula for this is if I've got a base, and that base is raised to a power. Like let's say a is 2, and then we have that whole thing raised to another power. What is the pattern to simplify? Well, you just multiply the two powers and keep the base. So what do? I raise the coefficients to the power like I showed you, and then you multiply the exponents. Okay? So again, this is not like a proof, but it's a way to show you that it does work. So I've got 2 squared to the 3rd power, so that's saying 2 squared times 2 squared times 2 squared. And when I expand this, I get 2 times 2 times 2 times 2 times 2 times 2 times 2. And how many 2's do I have? I get 6. And then if I go back up here, I can see that 2 times 3 equals 6. Okay? So there's the pattern. And the reason we have patterns is because do you want to expand this every time? Like, this takes way too long when we have a quick little trick where I can just look at the problem and know what to do. Okay? So let's do a few more examples with the trick we just learned. Okay? And I'm going to put a couple examples in here when we have more variables, but the trick stays the same. So the first thing that I want to show you with this trick is how to help you keep your numbers straight, because it starts to get messy. So one of my dead set rules here is that you always put the coefficient, or not even the coefficient, but the numbers. You put the coefficients in parentheses. Okay? Always, always, always do this. Okay? The other thing you should always do is label your invisible ones. Before you even start the problem, you need to do these two things. Put your coefficients in parentheses and label your invisible ones. And I'm going to show you why in this first example. Okay? Now I sound intense because I've been doing this a long time and I see this mistake a lot. So I see my -6. So I'm going to take my pencil or pen and I'm going to put that -6 in parentheses. Okay? Now, I'm going to label that with an exponent of 1. Okay? I know it's invisible, it's there. I'm just going to label it to help me. And then what I'm going to do is I'm going to draw this little thing. I'm going to take the 3 and I'm going to kind of draw a little distribution thing. Because I've got 3 exponents in there, and I need to raise all 3 of those exponents to that power. So what I end up getting is I'm going to keep the -6 in parentheses, and then what is 1 times 3? 3. Keep my x. What is 6 times 3? 18. What is 4 times 3? 12. So do you see how I've created new exponents with my rule of multiplying? Now the last trick is I can't have this thing, right? That's not simplified. So what am I going to use? I'm going to go to my calculator because I love my calculator. I'm going to go here, I'm going to put in parentheses, -6 parentheses to the third power, and hit enter, and I get negative 216. So my final answer for this is negative 216, x to the 18th, y to the 12th. Okay? I know this is overwhelming right now. It gets a little complicated, but I know all of you can do this if you just take your time and follow my pattern and what I'm doing. Okay, if you decide not to use parentheses, yeah, you're going to really struggle. So we're going to make that a habit. Every time we're going to use parentheses. So number 2, I see a number. I'm going to put that in parentheses right here. I'm going to put my little invisible 1. I also have an invisible 1 above that u. Do you see how the u doesn't have doesn't have an exponent? So I'm going to draw in a little 1 for it. Because now, when I do my little trick, where I distribute the exponent to what's inside, now I can say, okay, the negative 2 stays in parentheses, and what's that invisible 1 times 3? It's 3 now. The u term, what's 1 times 3? 3. And then the v term, 4 times 3 is 12. Okay? If you forget to put the 1 in, you might forget to distribute the 4. It happens a lot. I've seen it a lot, so be careful. Negative 2 to the third power, you're free to use your calculator. I know in my head that's negative 8. So this is your final answer for this. Okay? Last problem, if you want to pause right now and try it on your own, you're more than welcome. I'm going to show you, but it should be something you can do after I've shown you these 2 examples, so you're free to pause and try on your own. Okay. So again, I'm going to put my parentheses here and put an invisible 1. I am then going to distribute that exponent like this. Okay, it helps make the sound effects. Put the negative 3 in parentheses and now multiply. 6 times 1 is 6. Now I'm going to do my m. 6 times 4 is 24. Then I'm going to do my n. 6 times 6 is 36. To simplify negative 3 to the 6th power, I do need my calculator for that. So I'm going to do negative 3 parentheses to the 6th power, and I'm going to get 729. So my final answer is 729, and then m to the 24, n to the 36. Okay? That is the power rule, okay? You multiply powers when you have an exponent to an exponent. Okay, now here's where it starts to get a little harder, okay? Now we're going to, for the next couple examples, we're going to combine what we just learned with what we learned in the last learning target. So we're going to combine the product rule and the power rule. I don't want you to panic. Okay, this is all something that you're capable of. It just takes a little bit of slow thinking and taking your time. Okay, so I have this trick of working from the inside out, which basically means that you always do your parentheses first. What's inside the parentheses first, and then you do the power rule. Okay, so let's take a look at this first problem. I've got negative n to the 4th times n to the 3rd raised to the 3rd power. I'm going to ignore this 3rd power right now because I have to simplify what's inside. Well, negative n to the 4th times n to the 3rd, remember, if you're timesing 2 terms, you add the exponents. Okay, so I have a 4 and a 3 here, so I'm going to have negative n to the 7th. And then you bring it up to the 3rd power. Okay? So I'm going to cancel those out, and now I've just got this 3rd power. Now we use the power rule where we're going to put things in parentheses. Now be very careful here. This is a negative n to the 7th, so I'm going to write in the invisible 1. I'm going to put it in parentheses, and I'm going to put another 1 above it. Whenever you have a negative by itself, you need to do this. It's the one, I mean, of all the mistakes students make, that's it right there, the sign error. Okay? So I've put my negative in parentheses, I've put the negative 1 inside, and I've put the negative 1 up top. Now I can do the thing where I distribute the 3. So I have a negative 1 inside of here. 1 times 3 is 3. 7 times 3 is 21. And then negative 1 to the 3rd power is just negative 1. So I get negative 1 to the 21, and the best way to write that is like this. Okay? Alright, so far so good. Let's try the second one. The second one, I'm going to look what's inside the parentheses. I'm going to ask myself, can I simplify that? Am I multiplying anything by that? No. So I'm going to leave that alone. Can I simplify this thing? Nope. I'm going to leave that alone too. So what I'm going to do now, because I can't multiply those because I've got this pesky little 6 right here. I'm going to go ahead and get rid of that now. So I'm going to put this in parentheses like I've taught you. Put a 1 here. I'm going to distribute the 6 to this guy. So I'm going to have a negative 2 in parentheses. This exponent of 1 times 6 gives me 6. 5 times 6 gives me 30, so that becomes into the 30. And then this guy right here, I'm not doing anything to it, so I'm going to just bring it down. Okay? Now I changed the parentheses to a times symbol. That's okay, because I know parentheses means times. Alright? Now I'm going to do one step, and that's to put this negative 2 to the 6 in my calculator. Okay? So parentheses, a negative 2 to the 6th power is going to give me 64. So this becomes 64. And I'm just going to bring everything else down. I don't like doing multiple steps at once. It leads me to making mistakes. So now my next step is let's multiply the coefficients. And now that I've just got a times, I'm going to add these exponents. So 64 times negative 2, I've got my calculator here, gives me negative 128. So negative 128. So there I'm done with the numbers. And then 30 plus 4 is 34, so I have n to the 34. Notice how neat my work is. Notice how I'm carrying it down and it starts to get smaller. This is critical for this unit, okay? So be really, really careful. We are skipping this problem. You'll never see a problem like it in this unit. It's not necessary, so skip this problem, okay? I didn't take it off your packet, but we're just going to put the word skip and move on, okay? So, we've got 3 more types of problems, and these are the hardest ones you're going to see for this learning target, okay? Alright, the first one. I don't have anything to simplify inside the parentheses, so I'm going to go ahead and do the power rule to each of these first. Again, first step is to put this stuff in parentheses and put an invisible 1. Parentheses, invisible 1. Every single time you're going to do this, no matter what. Now you can distribute the exponent to what's inside. Alright, so this first thing is I've got negative 2 as my base, and then 1 times 5 is 5. Then I have n, 6 times 5 is 30. Bring down your times symbol, put this 2, leave it in parentheses. The exponent's 1, 1 times 3 is 3. Your next base is m, and then 3 times 3 is 9. Okay? Now, I'm going to use my calculator, because that is some math I don't want to do in my head. I've got negative 2 to the 5th, so parentheses negative 2, parentheses to the 5th, and that's going to give me negative 32. So I'm going to cross this off and write negative 32, bring down the end of the 30, and then 2 to the 3rd power, if you're not sure, and that's fine, 2 to the 3rd power is 8. So now you've got times 8m to the 9th. Okay, now I've got this n and this m. Now these are not the same base. Those are different bases, so we can't do anything with them. You cannot add exponents or whatever with different bases. It doesn't work. So I'm just going to bring these down. N to the 30, m to the 9th, and I'm going to be done with them. I'm going to cross them out. So now what's left is to actually multiply these two numbers. So in my calculator, I'm going to do negative 32 times 8 to give me negative 256. So that's what's going to go in front of here. Negative 256, n to the 30, m to the 9th. Okay? You guys still with me? We got 2 more left. I know this is a lot. I know it's complicated, but we got this. You guys can totally do it. You're all very bright. Okay? Alright, next problem. I don't have anything to simplify inside the parentheses just like last time, so this problem is very similar to this problem. The only difference is you've got to know that this means times. So if you want to write that little dot in there, that's cool with me. Okay? Put your little parentheses around here and put your invisible 1. Parentheses around here, invisible 1. Now you can draw your little distribution lines. Okay? So the first thing I have is a base of 2, and its new exponent is 3. 1 times 3 is 3. Base A, 2 times 3 is 6. Base B, 3 times 3 is 9. So that's my first part. Then I'm going to keep the negative 2 in parentheses. 1 times 4 is 4. I've got a base of A, and 2 times 4 is 8. Base B, and then 5 times 4 is 20. I know my B's look like 6's, and it's very confusing. I'm sorry. Okay, so now my next step, what I'm going to do is I'm going to look at my A's, and I'm going to combine those here. Okay, so a to the 6th times a to the 8th, we're going to add these two exponents. So I'm going to have a to the 14th, and I'm going to draw a big line through them. Cool, I'm done with my a's. My b's, I've got b to the 9th, b to the 20th. I'm going to add those now, not multiply them, to get b to the 29. Done. Now I just got to worry about this 2 to the 3rd and negative 2 to the 4th. I know 2 to the 3rd is 8. I'm going to cross it off and write 8. And negative 2 to the 4th, I'm going to put parentheses, negative 2 to the 4th, and I get 16. So I'm going to cross this guy off and put 16, and then I'm going to multiply the 16 times the 8. And I get 128. So this is my final answer right here. Notice all of the organization I use. I'm going to keep saying this. I put my coefficients in parentheses. I put my invisible ones. I used my crossing off technique. I circled the 8 and the 16. Like, I need you guys to do those things, okay? And if you come to me and don't have that stuff done, I'm going to send you guys back and tell you to do that, okay? I'm going to be really strict about it, okay? Last one here. Got a lot of weird negatives going on. How do we deal with this situation? Well, first of all, write in all your ones. That's a negative 1, that's a negative 1, that's a negative 1. That's just the first thing we got to do, okay? I'm going to deal with what's inside this parentheses first, so I'm going to put the negative 1 in parentheses and invisible exponent of 1 here. Now we're going to distribute the 6, okay? I'm going to carry down all this crud. Negative 1, x to the 6, y to the 3rd, because I can't do it yet. And then I'm going to simplify the parentheses. I've got negative 1 as my base. 1 times 6 is 6, okay? Then I have an x as a base, and 3 times 6 is 18. Then I have a y as a base, and I get 2 times 6, which is 12. And then I'm going to carry down the rest of this, okay? All right, now, you've got negative 1 to the 6th power, okay? Negative 1 to the 6th power, I know from the pattern that it's going to be a positive 1. Okay, and if you want to, you can put this in your calculator. I hope after a while you'll get that pattern. But negative 1 to the 6 is positive 1, so I'm just going to cross that off because it's just positive 1. It doesn't change anything. And then when I look at the other numbers I have left over, I'm going to circle them with a color. I have a negative 1 here and a negative 1 here. Well, what's negative 1 times negative 1? Positive 1. So that guy goes away too, which is really awesome, right? We don't even have to write anything down. We just know that they turn into a 1 and 1s are invisible. So now all we have to do is worry about our x's and our y's. Well, x to the 6th, x to the 18th, x to the 6th. So now we're going to have to add these together. So I've got x to the 6th, so 6 plus 18 plus 6. That's 12 plus 18. That's going to give me x to the 30th. Okay, and you can always use your calculator. And then I'm going to cancel these out because I don't want to get confused. Now I've got my y's left. I've got y to the 3rd, y to the 12th, and y to the 3rd. Well, that's 12 plus 6. That gives me y to the 18th, and that is my final answer. Do you see how something really crazy complicated turned into something very simple? Okay, so be aware that this is tricky. This is a lot of work, and it is a lot of organization, okay? If this one takes you a couple days, I get it, but I don't want you guys to give up. You're perfectly capable, okay? Please come talk to me if you need help and use my tricks, all right? Good luck, guys.